All right, hello everybody. So today we are going to continue with differences of squares. We learned this in the last video, so we're just going to do some more examples today that require a little bit more steps, so more things to look at. So this is just factoring difference of squares part 2. So we're just going to take a look at some more complicated examples today. All right, so let's go ahead and get started. So we're going to look at some examples today that have a GCF to take out first. So this is something we've been doing, throughout the entire factoring unit. We kind of start with the basics and then we add in a GCF. So remember, your first step of factoring should always be looking for a greatest common factor. So let's go ahead and do that. So look for a greatest common factor first. That's our first step here. So if we look at this example, does it have a greatest common factor? And it looks like it does, right? So look, if you look at the numbers, 2 and 72, well, 2 can go into both of those. So you definitely want to take out the 2 because it can go into both. So let's go ahead and do that. If I take out the 2, I'm going to write it on the outside. What would I have left over? So I'm basically just dividing both of these by 2. So here the 2's would cancel, so I would just have x squared, and then 72 divided by 2. If you need to use a calculator, then use a calculator, but 72 divided by 2 is 36, so I'm going to write minus 36. Okay, and then the next thing that you should always do is take a look at your parentheses, whatever's in the parentheses, and see if you can factor that even further. So if we look at that, let's see if we can factor that even further. Does that look like a difference of 2 squares? Well, it definitely looks like a difference, right? There's subtraction. Can I take the square root of this? And can I take the square root of this? That's what you need to be asking yourself. If I can take the square root of each of these, then I can factor this even further. And we definitely can, right? So what's the square root of x squared? Well, that would just be x. And the square root of 36 is 6. So what we're going to do is take this parentheses and we're going to break it down even further. We're still going to have the 2 on the outside. So we're still going to have that on the outside, but we're going to factor this just like we were doing in the previous video. So remember that one of them is a plus, one of them is a minus, and then you go ahead and write in those square roots. So x and 6, and then this would be completely factored. So we're going to do some more examples like that. So remember, just look for a greatest common factor first and take that out, and then see if you can factor this difference of squares. So let's go ahead and do some more. Okay, so factor each below completely. Anytime you see that completely, that's kind of a hint that typically means that there's multiple things you got to do. So let's take a look at this one. Does this have a greatest common factor? So let's think about that. Is there something that goes into 18 and 50? And there is. That would be 2 again. So the greatest common factor is 2. So we're going to put the 2 on the outside. So if I divide each of these by 2, well, this would become 18 divided by 2 is 9. So this would become 9x squared. And then 50 divided by 2 is 25. So minus 25. And then let's see if we can factor this again. So take a look at what's left here. 9x squared plus or minus 25. Is that a difference of squares? So let's try it. Can we take the square root? What's the square root of 9x squared? Well, that would be 3x, right? Because the square root of 9 is 3, and the square root of x squared is just x. All right, let's do the 25. So square root of 25, well, that would just be 5. So we're going to go ahead and factor this one. We're going to write out our factors like we normally do. 1 is a plus, 1 is a minus, 3x, and 5. And don't forget to bring down that 2. That 2 has to stay on the outside. All right, there we go. Okay, so let's take a look at this one. This one looks a little different because they both have the letter B. So when we're looking for a GCF, just know that we're going to have to take out one of the B's as well. So let's start with the coefficients though. So greatest common factor of 45 and 20. So what would go into 45 and 20? Well, definitely 5. 5 goes into both of those. And remember, since they both have B's, we can take out one of the B's because this one only has 1 to get rid of. So we're going to take out 5B. That's our greatest common factor. So we're going to divide both of these by 5B. And let's see what we have left. 45 divided by 5, well, that's 9. And we would have 2 of the b's left over, right? So it'd be b squared. And then let's see, 20 divided by 5 is 4, so we'll put minus 4. And the b's would just cancel, so that would just be minus 4. And then let's try to do difference of squares. So can I take the square root of each of these? Let's see. Square root of 9b squared. Well, we already did that one in the previous example. That would just be 3b. And then the square root of 4 is 2. So this one can definitely be factored again. So we're going to write out the 5b, and then we'll put our 2 factors. So plus minus 3b plus 2 and 3b minus 2. All right, and that one's all done. Okay, so this one has a lot going on. It looks like multiple letters are here. So let's just take it one step at a time. Let's start with the numbers, the coefficients. What goes into both of those? Well, definitely 8, right? 8 goes into 8, and 8 goes into 32. So we're definitely going to take out an 8. Can I take out any x's? It doesn't look like we can, right? Because this one over here, it doesn't have any x's. So I can't take out any of the x's. But I can take out the y, because they both have at least one y. So we're going to take out y. So that would be our greatest common factor. And then let's just divide and see what we got left. So the 8's would cancel, the y's would cancel. So the only thing I have left here is x squared. And then over in the second term, 32 divided by 8 is 4. So we'll put minus 4. And then the y's, if I divide those, I would have 2 left over. So 4y squared. Okay, and then let's try to take the square roots, just like we were doing before. So can I take the square root of this? Yep, that would just be x. And can I take the square root of this? Well, the square root of 4 is 2, and then the square root of y squared is y. So there we go. We would have our 8y on the outside, and then x plus 2y, and x minus 2y. Okay, and one more example over here. So let's find a greatest common factor, see if there's a greatest common factor. This one you might have to think about a little bit more. These numbers, they definitely do have a GCF. So if you need to list out your factors and try to figure that out, you can pause and try to do that. But the greatest common factor here is 6. 6 goes into both of those. And we can't take out any of the letters because they have different letters, right? Those have an A and that one has a B. So we're just going to divide by 6 here. So 24 divided by 6 is 4. So we would have 4a squared. And then 54 divided by 6 is 9. So minus 9b squared. And then let's just take the square roots. So square root of 4a squared, that would be 2a. And the square root of 9b squared, that would be 3b. And then let's list them out. 2a plus 3b, 2a minus 3b, and then don't forget that 6 on the outside. Okay, so that is how you factor a difference of squares when there's a GCF. And now we're going to look at a different scenario. So sometimes after you factor a difference of squares, you're going to end up with another difference of squares, and that needs to be factored also. So we're going to see that happen in this example here. So remember, always look for a GCF first, but it doesn't look like there is one, right? Is there a GCF of 81 and x to the 4th? No, there's not, right? The only thing we could take out is a 1, but that wouldn't really do anything for us. So we're just going to go ahead and try to factor this one. Can I take the square root of this and this? And it looks like we can, right? The square root of x to the 4th, that would be x squared, and the square root of 81 is 9. So let's write out our factors here. So we would have x squared plus 9 and x squared minus 9. And now you need to look at this very carefully. So look at what you have left. There is actually another difference of squares in this answer here. So this one, it's definitely not this part because that's a plus sign, right? Remember that you only can do this if it's subtraction. So it's not going to be the first part. But if you look at the second part, this is actually another difference of squares because it's a subtraction problem and each of these has a square root. So when this happens, you need to factor this even further. So we're still going to have this part. We can't change this part. I'm just going to go ahead and drop that down. X squared plus 9. But this we can factor again. So the x square root of x squared, well, that's just going to be x, and the square root of 9 is 3. So I'm going to write these in here as x plus 3 and x minus 3. So our final answer for this one would actually have 3 sets of parentheses because it's got 3 factors. So you just have to always be careful with that. It's always a good idea after you factor something to take a look at what you have left and just ask yourself, can I factor this any further? Can I factor this any further? Because that's how factoring works. You have to keep factoring until it can't be factored anymore. So this right here would be the final answer. So let's do a couple more examples of that. Okay, so in the first one, first, always make sure there's no GCF, and it doesn't look like there is, so let's just go ahead and start factoring. It's definitely a difference, so we can try to take the square roots here. So let's see, square root of r to the 4th is r to the 2nd, and the square root of 16s to the 4th, well, that would be 4, because the square root of 16 is 4, and then s to the 2nd. So let's go ahead and write out our factors. So remember, one of them is going to be a plus, one of them is going to be a minus, and then we would have r squared and 4s squared. And then we need to take a look at what we got left. So this part, I can't do anything else with that because that's a plus sign. So that is completely factored. However, this one has a minus sign. So I just need to double check if it has a minus sign, if it's a subtraction, can we factor it like a difference of squares? Let's see. If I can take the square root of each of these, then we can absolutely factor it. So let's see, the square root of r squared is r, and the square root of 4s squared, that's 2s. So since I could take the square roots, I need to write this out as 2 factors, just like we normally would do. So plus, minus, oops, this would be a minus. And then we would have r and 2s, r and 2s. And then this first one, the one we couldn't do anything with, we're just going to bring that down. So r squared plus 4s squared. And then this would be our final answer here, all 3 of those. Okay, let's do one more. Now this one looks pretty simple, doesn't it? But you're going to see that the same thing's going to happen here. So if I take the square root of x to the 4th, that's just x squared. And if I take the square root of 1, well, the square root of 1 is just 1. So when we write out our factors, it would be x squared plus 1 and x squared minus 1. And then just double check, see if you got another difference of squares here. It's definitely not the first one, right? The second one, though, it's a difference, and this you actually can take the square root of each of these because the square root of x squared is x, and the square root of 1 is 1. So we would go ahead and factor this into x plus 1 and x minus 1. And then we'll just bring down that first part, x squared plus 1. And there we go. That would be completely factored. Okay, that is it for this video, guys. See you next time.